Hey folks, I'm over here working on the throttle for my Merit's Pioneer 2 electric mobility scooter, aka wheelchair. I've done a lot of repair videos and instructions on this thing, but I'm taking another deep dive into this because I now have a lot more skills to offer to and materials to offer to improving this. And so I'd like to do a little bit of a rundown of what you can do, various ways to improve and repair these throttle controls, which break very often because they're used very often. And I'm also going to go over some of the engineering flaws, some pretty significant ones actually in this one. And, and then finally, I'm going to talk about some of the upgrades that I would like to do to basically really almost rework this completely from the ground up. So first, an overview of what this is. This is, of course, the throttle that goes forward or reverse in a mobility scooter for disabled folks and seniors and folks. And these are controlled with what's called a potentiometer. This is a variable resistor and specifically a very high precision logarithmic potentiometer that lets the computer, the microcontroller in your motor controller, know what status it is being turned at, and then basically it says, okay, if this is at this position or this position or this position, it will adjust the speed, the acceleration, and other things within the microcontroller that controls the motor H bridge, which then goes to the transaxle motor and turns everything. But I'll talk more about that another time. The important thing to know is that this is just a knob that turns. It's a potentiometer, changes the resistance between these two wires and these two wires. The white wire here is the wiper blade, and that basically moves along two resistors. That's how a potentiometer works. And if this potentiometer becomes a little bit uncalibrated, as it is right now, then you get all sorts of issues. First off, with my microcontroller, which is very common, is it expects the levers to be center during startup. And if it's not, you'll actually just get an error signal. So I think what a lot of folks probably find is on startup, you have to kind of like nudge this in one direction either, whatever direction's a little bit off, to kind of tell it, okay, start up now. It starts up because it thinks that's the center. You let go and it either goes in reverse or it just won't go full speed one direction because you're already off center. So when you start pulling it down or forward, it won't go all the way. And so that is basically what happens when these potentiometers become out of calibration. And you'll see here in my notes here, I've actually made this a long time ago and I used like a micro pen. This is kind of cool. But it says potentiometer, or POT for short, sweet spot. And for this particular potentiometer, the microcontroller seems to really like it if on one side it's at 3K5 and the other it's at 2K3. Now it's a 5K pot, so there's some variation in that probably. These are measurements with this disconnected. Very important to measure the potentiometer when it's not connected to anything. I should double check what kind of connector this is. These are actually quite available. I believe it's a type of JST. Obviously, it's a 3-pin. Really helpful if you can get the mating connector like I have here. It really makes it a lot easier to take measurements and stuff. As you can see here, I'm using clip probes. These are really great. They're little spring-loaded clips on the end of these. And really great for taking readings of stuff like this. So obviously I have that reading. There's going to be a reading misalignment. The other issues you can have, of course, is dust and particles, contaminants getting in these potentiometers, and just, failure of any other sort. But normally it's just a calibration kind of, an issue of basically these set screws. I'll go ahead and zoom in here now. You'll see we have a set screw here, and there's actually one on each side for this particular throttle control mech. Here's the other one down here. And these are 2.5 millimeter hex set screws. And so you can undo these, turn to the right, of course. Sorry, to the left, counterclockwise. And you undo those on both sides, and then this can actually come out. Now, and this here, of course, you'll see this is just potentiometer. It's got a longer than usual shaft, though, and because of its high precision and very precise logarithmic setup, it's actually only designed to be turned very, very slightly, but to go, you know, kind of large distances in the resistive element. So what that means is that you can't, this really sucks, but you cannot just use regular potentiometers. And these ones can be extremely hard to source, and stupid, evil wheelchair resellers like Monster Scooter Parts, may you burn in hell, upsell these to ghastly amounts. I've seen these like throttle lever things sell for like $50 and crap like that. I mean, absolute garbage. This is a $5 part at most. At most. This is a $5 or $10 part at most. I mean, you do have like the metal here, but even I've seen just these pots being sold for insane prices, $30, $40. The way that they exploit us as disabled people is disgusting. And as you watch my videos, I will be ranting about that a lot because it's really unfair. Not everyone has insurance and special companies to pay all your bills. A lot of disabled people have to pay this out of pocket. And so that's one of the reasons I make videos like this, to help you repair your stuff. So one thing that you can do if your potentiometer has like a lot of gunk and it's basically not giving you consistent readings when you turn it, is there is a type of spray that you can actually put into the, basically into the shaft there in that crevice, and this is a deoxit spray. And so it's mainly used for audio and video interconnects, but potentiometers on mixers and stuff like that, this stuff is amazing. And so it's a great way to clean up your potentiometer if you have any issues. I'm going to go ahead and just use a little bit of it anyway because it's not going to hurt. But it basically helps increase conductivity between the wiper blade and the resistive element within the potentiometer. And I guess it does that because this has a slightly conductive property to it. And you don't need a lot, just a little tiny bit. In fact, that's probably all I need, which is why that bottle's lasted me for years and years. And so once you spray it in there, you're just going to give it a little bit of a turn over and over again to make sure that it kind of works its way down in there. And of course, the idea is that this is sealed as much as possible so that, you know, all sorts of little contaminants don't get up in here. And one of the better engineering choices is that it's facing down, which makes the rain or whatever else, things falling, crumbs, don't get anywhere near this potentiometer. And so for that reason, I will say that this is not commonly the issue of actually having dead spots within the resistive track within the potentiometer. At least I haven't come across that too much. And so I'm just working this in here a little bit. Okay. And now, I mean, we can go ahead and take a look at some readings just to give you an idea of how to do this. And keep in mind, I'm still just doing kind of an overview, but I'll go into more of the repair details and more of the design details. This is going to be a longer video just because I don't think there's a lot of this information out there, and I'd like to provide it. So I'm going to go here into my ohm setting on my multimeter, and I've got the two probes hooked up, and you'll see here it's measuring 5K4, and that's a very, very large reading, even though this is a 5K pot, so I'm not sure why that is. A lot of times these things are just not as accurate as, not exactly 5K the way you'd like them. Yeah, so you'll see here, this is why this thing is so specialized as far as potentiometers go. Let me go ahead and actually, I don't know, I kind of want to take this spring out. It's annoying. But you'll see here, just the slightest turn jumps it up. It's very, very sensitive right in that middle area. And you'll see here that it's already at 0. So it doesn't take hardly any turning at all. And that, of course, is, you know, just measured by the microcontroller. So yeah, finding that sweet spot, which is super annoying. It's actually not in the middle of the pot. It's when I get these two readings. Also, when you do find that sweet spot, it's a really good idea to plug it back into your mobility scooter and double check that the microcontroller sees that as the off state. So one of the things you're doing when you're calibrating this is you're plugging it back in. In my case, it's kind of tricky to do. I don't have great wheelchair access to my mobility scooter, especially when it's being repaired. So keep that in mind. You do need to kind of go back and forth and double check on things like that. But this process can be really tedious because every time it's wrong, you just have to go and undo those set screws, take this off. I would just go ahead and maybe just remove, you can you can unclip this little spring, but I'm going to keep it on because I want to show you something else in a minute. But you can unclip this spring, so otherwise you're hurting your hand. At least I am, like pushing this up and then turning this over and over again. But that's kind of what you have to do. You have to get your clip probes on here, get your measurement. Again, really helps if you have a mating jack like this, and then turn it like so until you get to that sweet spot, that off state that the microcontroller likes. And of course you unplug it here, plug it back into the microcontroller, turn your key over, see if it likes it. And then if it does and everything's happy, then you can get this guy back on here and secure it nice and tightly. So that's problem number one. Problem number two, which is really annoying, is an engineering fault. And you'll see here on this plate, we've got one spring, which has quite a lot of tension. And that, of course, is to spring back to a home state when you let go. It pulls the lever back. I'm going to sort of rant a little bit because I think this is very bad engineering for a couple of reasons. One, this spring is way too strong, which means that for disabled people and those with arthritis, this hurts. Doing this all freaking day hurts, and unnecessarily. And so there's that part of it. The spring tension is just much tighter than it needs to be. The other part of it is it's only springed on one side, which means I think it's very possible, especially because these kind of, I guess you could call them roller pins, but they don't actually roll. These can come loose. There's a flathead on one side and then just a lock nut on the other. Let's hope it's a lock nut and not just a regular nut. Looks like it's a lock nut. And you'll see there are these two pieces of metal. And so when you turn this, it either pushes this side up with the spring mech, right? Or it pushes it up that way over there with the spring mech. But again, this would be much better suited if you had two springs to equalize the tension on here. If the tension's not equal, you're much more likely to have angular pressure on the shaft of this potentiometer, which can break it. Also, when you don't have even pressure, you're going to have issues with these coming loose, as they did in my case. What's worse, and what's more, is you have metal rubbing against metal here, and really what they should have is some small roller bearings. There's no reason for that. And so that's also quite a bad design. Even worse, if you're reassembling this thing, this has to be, you can't push this down all the way because then it starts to hit the locking nut for the potentiometer. You see there, it gets kind of caught. So it's up to the user to kind of eyeball this and try to find a good spot like there where it's actually hitting these metal tabs like it's supposed to, but then not hitting the nut. So that gives you an arbitrary Z height for which to secure your Allen lock nuts here. Really stupid. And then maybe the worst thing of all is that this is not a knurled shaft and it's not a type D shaft. It is a completely smooth spherical shaft, which is super dumb because that means you're relying solely on the pressure and sort of metal against metal force of the shaft to keep this big heavy thing locked onto it. Really, really bad design. And again, can, and I'm sure does, lead to failures. So it's really relying on all this, but but it's all metal, so yay. I don't know. Maybe that's what they're thinking. Like, look, it's welded metal. It's so nice. Welded metal doesn't mean anything when you've got really bad engineering like this. And as you can see, it also develops rust. So, so yeah, those are the problems. And the way to do this, I'll just try to explain it one more time, is of course, you have to take this off. You undo the two. Well, let me back up a second. First, you have to take this plate out. This plate is secured through 1, 2, 3 Phillips screws in my Merit's Pioneer 2. You undo the plug for the potentiometer. If it isn't there already, I would redo some of the solder connections here with better solder. And you can see I put heat shrink tubing on those pins as well. Really important to have this be a good solid connection. Take this out, undo the 2 locking Allen screws for the shaft of the potentiometer. Replace the potentiometer if you need to, but I really doubt you do. At least I haven't run into that too much. I'm trying to think if I've ever had to replace it. But then you got to take hopefully you have a mating connector, or you have to undo the sleeves here to get some probes. Highly recommend using locking probes like this. You can get these for about $10 off eBay. Most of them have screw terminals, an inner threaded screw that requires a threaded, I guess I'll show you real quick, a threaded probe. And it's usually a 4mm or an M4 thread. So if you're looking out for those, try to get it with the probes if you can. And they sell various versions of these, but I like this style the most by far. Much better quality than some of the other ones out there. This is sort of an oscilloscope style probe clip. And so yeah, this is the easiest and best way to do it that I've found. You get your probes on here, you get your mating connector, and then you use your oscilloscope, I'm sorry, your DMM, your digital multimeter, turn it to ohms, and then you turn this knob to get to the sweet spot, and then you reapply this guy. And when you reapply this guy, make sure, the other thing is these 2 pins they're off, they're not matching, right? They're different. So you can't have it this way, or it's actually totally off. You can see there. So it's got to be the right direction. Then you got to lift this up, either remove the spring or use your fingers to push up the spring tension, to loosen the spring tension. Push this down, you got to kind of eyeball it so it's not hitting the locking nut here. I'll zoom a little more so you can see that. Once you get it to where you like, secure these 2, and then reinstall everything back, undo this, and then reinstall the 3 screws. But again, when you're testing this, you'll want to plug it into your microcontroller occasionally to make sure that you've hit that sweet spot. So that's the repair info. All right. If you're still with me, I'm going to talk about how I'm going to make this better, time permitting. I'd really like to improve this a lot. So thing number 1 is I actually want to model this plate here. This is a flat plate, and there's lots of space inside the panel and what's called the tiller assembly for this to be larger if I want it, although I might not need that. All I really need is these 3 openings to mount it. And so I'd like to recreate this plate and then actually have it have dual spring tensions and possibly a roller. I also would really like to get rid of this analog pot, substitute it for a digital potentiometer, which I would control. Ideally, this would be controlled with a rotary encoder. Welcome to the year like 1995. Rotary encoders are much better suited for this kind of thing, and it's really ridiculous that they're relying on a mechanical pot. Mechanical pots are very good for analog control. You know, if you're trying to control an analog audio signal and you don't want to have it interface due to like digital noise, you know, in a hi-fi audiophile circuit, that's when analog pots are great to be used. Or if you're trying to save a lot of, money, like maybe for a voltage regulator or something like that, they're pretty good for that too, for, a buck or boost converter kind of thing. To use an analog pot for a motor controller to control a motor that has a microcontroller already on it, is beyond stupid and is just totally corner cutting nonsense, and is prone to failure and extra expense, as I sure have found out. So we'll see what I have time to do, if I have time to do that whole digital circuit. I've already created some of the firmware for it a while back, and I've posted some videos about that elsewhere, which I might upload here. But at the very least today, I would like to 3D model this plate and see what I can do to make some improvements, even if I am going to keep this mostly stock. And then, of course, do that pot calibration as well. And maybe take some new measurements and find out a little more about that sweet spot. I've already years ago tried to source this guy for cheaper, and I think it's just really hard to find, even though I'm sure it's not that expensive when it was made, but we'll see. Anyway, that's the other advantage. If I made this a rotary encoder, of course, wouldn't have to go sourcing hard to find weird potentiometers. So that's it for this video of reverse engineering and repairing your throttle for a Merit's Pioneer 2. Obviously applicable to other throttle controlled mobility scooters. Hopefully you found some of this information useful. Please leave a comment or info or whatever if you like. I love hearing from people. I will try to reply the best I can if I can. But I always read the replies, and it's great to know if these videos are able to help folks out there. And yeah, there'll be a lot more to come after this. I'll be setting up a website and stuff like that as well, if I haven't already by the time of this video. So thanks for checking this out. Catch you all later.